Hi everyone, it's Miss Kennedy. I know it's been a while since I made a video, but I'm back. So this unit is all about air pollution, so that's what we're gonna kick it off with. I wanted to start with something funny because I found this on Facebook and I thought it was hilarious. So when squirrels land, they apparently land like little superheroes, which is super adorable and just makes me laugh. So not connected to squirrels at all, air pollution, which we're going to talk about, is a global system. It happens all over the planet and it affects everything and everyone. And really just a working definition of air pollution is this introduction of things like chemicals, particulate matter, which we'll get more into, and even microorganisms into our air or atmosphere at really high concentrations that can cause harm to plants, animals like us, things like buildings even, and they can change. The air pollution itself can change ecosystems. So this image kind of shows the major sources of pollution. You have natural sources, you have area sources like cities, farms, you have stationary sources, which are very common from power plants, industries like the fossil fuel industry, and sewage treatment facilities. And then you have mobile areas, mobile sources like planes, cars, trucks, etc. So I'm going to talk about the Clean Air Act, which is a super important law to know for the exam and for your life. It was created in the 70s by the United States government. It was designed to control air pollution on a national level, not just certain areas. And it requires the Environmental Protection Agency, or the EPA, to create these regulations to keep the public safe from airborne pollution. So the Clean Air Act that I just talked about identified 6 key pollutants that threaten us and our environment. They are really important to know. So these are the 6 right here. We're going to get more into them on the next slide, but just know that these are the 6 key pollutants. So you might ask, how do you remember these 6 pollutants? There's a couple different ways. So nose clip is all the gas of all. So the Clean Air Act is important for a lot of reasons, especially because it identified the 6 key pollutants that threaten us and our environment. These are the 6 here in this cloud, and the sources are kind of all around. But you will need to know these 6, and it's very important. And I have a very easy way of remembering it in case you're wondering, how will I remember all of these pollutants? There are a couple different ways. So nose clip is what they're all. If you put all their first letters together, it spells nose clip. You can remember it as a nose clip will save you from air pollution. So if you put like a clip over your nose, that will help save you. I remember it as no one said cats like pineapple, so each letter kind of forms one of those, I think it's called an acronym, I can't remember. No one said cats like pineapple. That's the same thing as nose clip, and it's all 6 of the major pollutants are in those little mnemonics, not acronyms, my bad, it's called a mnemonic. So the N is nitrogen oxides, the O is ozone, and this is ground level ozone, not stratospheric ozone, which is higher up. Sulfur dioxide is the S, carbon monoxide C, lead L, particulate matter is the final part. So that's nose clip, or no one said cats like pineapple. So the N in nose clip, or no one said cats like pineapple, stands for nitrogen oxides, which are nitrogen and oxygen in 2 forms, NO and NO2. The main sources of these pollutants are the mobile source, which is cars, trucks, that sort of thing, and then fossil fuels. Burning fossil fuels releases these pollutants into the atmosphere. There are minor sources that are natural things like forest fires, lightning, and even some organisms release these 2 gases into the atmosphere from soil. And these gases are a concern for humans because they irritate our respiratory system. They're a concern for our environment because they cause acid rain and smog. So again, that's nitrogen oxides, or the N in nose clip. So the O in nose clip stands for ozone, but I wrote ground level ozone because there are 2 types of ozone. There's this good layer that's in the stratosphere, so that's not the ground level at all, that's way higher. And it's good because it kind of protects us from UV radiation, or the radiation from the sun, so it acts like a kind of protective layer. So that's the good layer. The bad layer is the ground ozone, or the ozone that affects us because it's in the troposphere, it's in the air that we breathe, and so we'll focus on that type of ozone. So ozone is known as a secondary pollutant because it doesn't just exist after something pollutes the environment. Like a car doesn't just give off ozone. It's formed in a reaction. So sunlight and water will react with things like nitrogen oxides, VOCs, which are volatile organic compounds, and I'll get more into that, and even oxygen. So you take these things and you combine them with sunlight and water to get ozone. And I'll get more into that in just a minute. But ozone is a concern because it damages our human health, our respiratory system, and it can damage our ecosystems, our plants. So I'm briefly going to go over how ozone forms. I'm sorry if it gets a little confusing. But the first way is a natural process that occurs without us. So oxygen or dioxygen molecules, which are O2, they're split up by sunlight when they meet with sunlight. And that creates these free oxygens that will then bind to other dioxygen molecules. So this is your free oxygen binding with your dioxygen to create O3, which is ozone. So that's how you get ozone in nature. That's a natural process. There's also the human influence process where sunlight will create a reaction with things like nitrogen oxides, which we just talked about, and volatile organic compounds, which I will talk about. And that whole reaction, sunlight plus nitrogen oxides plus VOCs, creates ozone. So they all kind of bake together to create ozone. So I'm briefly going to go over some issues with both good and bad ozone. And just remember that good ozone is up in the stratosphere. It's the protective layer that shields us from the sun's harmful rays. So a while ago, there was a huge depletion of the ozone layer by things called chlorofluorocarbons, or CFCs. And these CFCs were released into the environment by industries. They were commonly found in spray cans like this, like in hairspray and air conditioners and refrigerants. So they're released, and then they basically destroy ozone, and we want ozone in that protective layer. So as more ozone gets depleted, more sunlight is able to reach Earth. So it caused this warming effect, which became very dangerous. So it kind of created this hole in the ozone layer that you might have heard of. And the consequences were somewhat obvious. That can increase your chance of skin cancer as you get more exposure to UV rays. Lead to skin ailments, it disrupts plant cycles, and destroys many ecosystems, including marine ecosystems. But the good news is that even NASA is saying that the ozone hole is shrinking because we've created many regulations against things like CFCs in hairsprays and aerosol cans. You probably won't find any if you look in your sprays that you just bought. They're banned in the United States, and industries are working on removing CFCs from things like air conditioners and refrigerators. So the good news is that the ozone hole is shrinking, and it's kind of one positive to all the bad. And now the issues with bad ozone. So we've increased the amount of nitrogen oxides and volatile organic compounds that we are allowing in the atmosphere because we're burning fossil fuels at a very high rate, and we're increasing the use of chemical solvents, which I'll get into more. So as these gases enter the atmosphere at higher rates, they interact with the sun and water to create ozone. Remember this image that I showed you before. This human influence process takes those two gases and creates ozone. But this doesn't happen in the good layer where we want it. It happens in the bad layer, the troposphere, where we live. So we don't want it happening in this layer for many reasons, but it's happening because we're adding more of these gases by burning fossil fuels, driving cars, and using chemicals. So the consequences of that increase in bad ozone are health problems like asthma and bronchitis. They damage our crops, our plants, you can see that here, and they impact the carbon cycle. And so this ozone is a greenhouse gas, meaning that it absorbs heat, which is why we want it in the ozone layer in the stratosphere, because it protects our planet from the sun, from too much sun. But if it's absorbing heat in the troposphere, that means it's just absorbing the heat from the Earth and creating like a hotter troposphere, which is where we live, so we don't want that. The S in nose clip stands for sulfur dioxides, which is 1 part sulfur and 2 parts oxygen. The main source of sulfur dioxides in our atmosphere are from fuel combustion, which is the burning of coal and oil in this case. Some can be released naturally from things like volcanoes and forest fires, but they're much smaller parts compared to the human sources of sulfur dioxide. It's a respiratory irritant again. It can affect plant tissues and cause acid rain, which I will get into more later. So the C in nose clip stands for carbon monoxide. You might have heard of this one. Carbon monoxide is formed during incomplete combustion of many types of matter, which just means that when it is reacting, there's not enough oxygen to create CO2, so carbon monoxide is created. A really common source is from vehicles, the exhaust from your car. And there are a lot of other sources as well, but it's super dangerous inside because you can't smell it, see it, or hear it, and it's very toxic to humans. So if your house has poor ventilation and any of these sources of carbon monoxide exist, you could be in danger of carbon monoxide poisoning. So take a look at the sources of carbon monoxide you can find in a home. Most of them are based on some sort of fuel or coal or oil being burned at some point, which would release carbon monoxide. The L in nose clip stands for lead. Lead is a naturally occurring metal that's found in our environment in small quantities. There are many sources or many places we've used lead in the past. It was used in gasoline at one point, but that was phased out in the 90s. It's used in paint. It was used in paint in older buildings, which was also deemed to be dangerous, and also used in pipes in places like Flint, Michigan. So you might be wondering, why are we using lead? Why were we using lead in so many products? And there are a number of reasons. Lead has a number of properties that are beneficial. It's strong, it can block out sounds, it helps paint dry, and it can even prevent corrosion or wear. So that's why it is used in paints and pipes and things like that. But it was also later found out that lead is very toxic to our nervous system and can cause quite a few health concerns, which is why we are trying to ban it from most products. And that's why Flint, Michigan is such a crisis, because there's so much lead in their water that it's causing serious health issues to the people that live there. So that's lead. The final step in nose clip, or the pineapple, and no one said cats like pineapple, is particulate matter. This is the sum of all the liquid and solid particles found in the air. Those can be things like dust, salt, and ash. And you can find these things in the air through the burning of fossil fuels and even biomass. So those things can release things into the air, particulates into the air. Burning diesel is much worse than gasoline, just as a side note. And things like dust, crushing of rocks through mining, volcanic eruptions, fires, and dust storms release a lot of particulate matter. And if it's heavy enough, the particulate matter can block sunlight, which would prevent photosynthesis. So it is a danger to our planet for that reason. So particulate matter can also affect human health based on its size. So here you have a human hair, this big large thing, and it's about 50 to 70 microns, which is super, super tiny, but that's the measurement we'll be talking about. Anything longer than, anything larger than 10 microns will generally be caught in your nose and your throat, and then it'll be filtered back out as mucus. So anything that's larger than these blue guys here will not make it into your body and cause damage. Particulates are very, very small, as you can tell. So the blue guys here are particulates that are 10 microns, and they are things like dust and pollen. They won't be filtered by your nose and your throat. They'll get into your body and they can cause damage. The even tinier ones, the red ones, are 2.5 microns, so they're super, super tiny, and there's a really serious health concern. They can lodge really deeply into your respiratory tract because they're so small, and they're very toxic and hard to treat. And those are different kinds of particulates from dust and pollen. Those are things like metals and organic compounds and more. So those, because they're so small, can cause a lot of damage to your health. So I'm briefly going to go over a few other major pollutants. I talked a lot about volatile organic compounds, or VOCs. They're gases that are emitted either from products that you see listed here in your home or from processes. And some are really harmful by themselves and can cause cancer. They can also do something where they react with other gases and form other air pollutants like ozone, as we talked about at the very beginning of this lecture. Plants also release VOCs, so they aren't occurring naturally, but humans have created quite a few products that contain them, and thus they're released into the environment and can cause a lot more damage to our planet. Another major pollutant is mercury. You've probably heard about this. It's released through coal and oil combustion, and it's increased in fish through this process of bioaccumulation, where mercury is emitted into the atmosphere, it falls onto land, it's stored in forests and lakes and rivers, and eventually gets into our oceans where our fish consume it, and then it starts to build up in their tissues. So mercury is a major concern for many reasons, but note that it comes from the burning of fossil fuels, which you probably didn't know. Another major pollutant that's very obvious is carbon dioxide, and we know the major sources of carbon dioxide are burning fossil fuels, driving cars, etc. And you can see that as carbon dioxide in our atmosphere increases, so does our temperature on our planet. It's a greenhouse gas and it warms our environment, so we should be concerned about the amount of carbon dioxide we're putting into the air. We're almost done. I just wanted to talk quickly about primary pollutants and secondary pollutants. So primary pollutants come directly from a source like an exhaust pipe of a car or a smokestack of a factory. Examples are things like nitrogen oxides, carbon monoxide, mercury, VOCs, and sulfur oxides. So they're released directly from these sources. Secondary pollutants have undergone some kind of transformation. They react with things like sunlight, water, oxygen, and other compounds. And these things generally occur in the daytime or in wet conditions where you would find a lot of sun and a lot of water. So remember that ozone reacts with sunlight and water and primary pollutants like nitrogen oxides to create ozone. So that would be a secondary pollutant. So that's it. Please remember, no one said cats like pineapples or nose clip. Nose clip will save you from air pollution like this girl here. So remember one of those two, whatever works for you. I hope you enjoyed. I know it was a lot of information, so pause, watch as many times as you need to. And no one said cats like pineapple. Don't forget it.